Hello everyone, welcome to Coder and Boots. In this video, we are going to discuss about a topic that answers the following questions. So how to deploy and basically how to build and deploy Docker image using GitLab CI, or maybe how to containerize and deploy your application using GitLab CI. Okay, so your application can be developed in any programming language like Python, Java, React, or web applications like React based web UI, Angular based web UI, HTML, or simple HTML, CSS, JavaScript based applications, or PHP based applications. It can be anything. Okay, so and if you want to containerize, Dockerize it, and you want to deploy in a Docker based environment, then this video will be helpful to you. Okay, so I'll just explain a basic workflow of this, and then I'll get into the technical demonstration of how we are going to do this kind of. So this is basically the simple workflow. So the developer will be developing the application code, and then he will be committing the code to the GitLab. So here I am demonstrating it using GitLab, but the same workflow is possible in GitLab, GitHub, Bitbucket, Azure DevOps, or any version control system. Okay, so the mechanism is the same. The way we write the workflow code is slightly different, but the idea is the same. The same workflow is possible. So I am going to explain it using GitLab. That's the reason I have used all the GitLab related icons. So developer commits the code gets committed to the GitLab repository, and then when the commit happens, basically a build job, basically a CA job gets triggered, and the CA job definition is basically embedded within the CA file. Okay, and what will happen, it will the job gets executed in the runner, and runner will install the dependencies and build the Docker image. Install the dependencies means, for example, in case of a Java program, so you will have so many Java dependencies, right, in the form of jars. You will have to build it, right? So you will have to pull these dependencies from the Maven repository and then create the build out of it. And then using this build, what we do, we create the Docker image. Okay, we build the Docker image and push the image to the container registry. In case of Python, what will happen, we have the Python program and we have the dependencies like the PyPy, the Python packages that needs to be downloaded from the PyPy repository. So we will do it using the pip install commands. We will install the packages, then build the program, build the Docker image, and push the Docker image to the container registry. Same will happen for React and Angular based applications. So there also, like, I mean, the npm packages will get downloaded, and the code will be built, and the Docker image also will be built, and then this bundled image will be pushed to the container registry. So this is the flow for the build. So this entire workflow, we can say it's a build job. So at the end of this particular workflow, what gets created is the Docker image. So in the container registry, the Docker image will be stored. Okay, this container registry is can be hosted in multiple places. So GitLab also has a container registry service, so we can store it in the GitLab container registry, or we have several container registries like Docker Hub. There are, like, I mean, container registries from Amazon, Azure, Google. So Amazon ECR, Azure has something called ACR, Google Cloud has container registry, and or you can even host container registries of your own. Okay, so basically we need an image registry to be or container registry to store the image. Okay, so once we have the stored image, then next is basically the deployment workflow. So what we will do is, in the container registry we will have the images, basically the versioned images. So we will have the build image with a version name, and with the version and the image name we will pull the image. Okay, and we will have a deployment specification. So we will have a workflow corresponding to the deployment. Basically at the time of deployment, what will happen, so we will need the image plus the configuration, and that gets deployed to the target environment. Target environment can be maybe a simple Docker runtime, or it can be a Kubernetes environment, or Kubernetes itself, I mean, it's provided by various service providers, or it can even be something that is manually installed, the vanilla Kubernetes. So depending upon where is the target environment, it can be deployed. Okay, so this workflows are very simple. Even the implementation of this entire workflow is also very simple. So let's get into the technical discussion quickly. Okay, So I'm going to show you two examples. One is basically the deployment, the build and deployment of a web UI code, and the build and deployment of the same or the similar build and deployment of a Python based program. Okay, so first I'll show I have used two different branches in the same repository for showing this, but usually we keep separate project repositories for Python and the UI code. But consider this is just a demonstration of this topic, right? So that's why I for easiness I just kept it in the same repository. So in this test branch I have basically a simple website. Okay, so this is a simple website, coders website 2.1. So a simple HTML file, and I have some GSS, CSS and JavaScript components. Okay, so think about like this is a simple website. So this can be Angular or React based application. So just for easiness or simplicity I just kept it like a basic HTML, CSS, JavaScript website. Okay, then next component is basically the Docker file. Okay, so Docker file here, if you see, as this is a web application, basically HTML JavaScript based web application, so I need to host this in a web server. Okay, so I used Nginx web server. So here I just used the tag latest from Nginx latest. So but you should never use latest. The reason is when we build this, what will happen is it will always pull the latest image. So you have to specify a version here. So right now I just specified latest, but it has to be like a version. So then what I'm doing is I'm copying the contents, site contents. Okay, what is site content? Basically from this directory, this is the site content. So you can update this based on your own directory. Site contents to USR share Nginx HTML. So this is the document root of Nginx. So I'm not going to explain a lot about Nginx because I've covered several videos that explains the internals of Nginx. Okay, you can refer to those videos for getting more understanding of Nginx. So once we copy this to the document root of this Nginx, what will happen? So it will be within the document root. So once this particular container starts, so then the website will get rendered. Okay, so on the default port you will see the contents of this website. So let's say if you want to do the deployment of Angular, then there will be some more steps in between. So what you will be doing is we will need to build the Angular code first. So we'll have to install the packages, dependencies, everything, build the Angular code. Then the build is what we need to copy to the HTML directory. Okay, so that steps we need to do it before, and then do this copy of this, and finally we'll have the image with the build version. Okay, so then next is basically the workflow. So that we will define it in the .gitlab CI YAML. Okay, so this is specific to GitLab. Okay, so here I have a build stage. So what I am going to use is I am using Docker and Docker mechanism. So what will happen is this is a privileged container where it can run Docker container within the Docker container itself. Okay, so and it's basically it has a lot of privileges. It can do create containers, okay, create image, build images, everything within the this DIND container. Okay, so inside this container what we are doing, so first is we are login to the we are doing a login to the registry. So what is this registry? I'm going to use the GitLab's registry. So if you see in the left hand side of the GitLab options menu, you will see something called package registry, container registry, model registry. So these are the artifact registries available in GitLab. Okay, so we'll be using the container registry feature because this is the place where we store the Docker images. Okay, so that's why we are doing a login to this particular container registry, and the $CI registry user, $CI registry password, $CI registry. So what will happen is at the time of running this particular pipeline, I don't have to explicitly pass this because as this is in GitLab's internal and this is within the same project. Because if you see this container registry, it is specific to each project. Okay, so so what will happen is it will take the default values. Okay, it will get the values assigned during the runtime. Okay, so these variables are GitLab specific. If you want to override, let's say if you want to push it to a third-party registry or a registry corresponding to a different project, what you can do, you can pass those variables and set the values Okay, so in GitLab variables, there is something called, in the settings section, there is something called CACD. Under this we have variables. We can set the values in the variables. Variables means if you want any sensitive variables, you can set it in the secrets, or if you want to pass anything during the runtime, you can even set the variables over here as well. Okay, so you can pass those variables and then do the login to the Docker registry, because if you don't do the login, what will happen? It won't authenticate. Okay, so that's the reason we are doing a login upfront. So post that, what we are doing, I'm just doing a print. I'm just printing the registry name and the image tag. Image tag I am keeping. See here, this is a variable. I am doing it as a latest. So this is the main command. So this is a docker command. So it's docker build docker build -t. Okay, so it is going to get built with this name. Okay, so this is the CA registry image image tag, and then dot means what? It will look for a Docker file in the current working directory. Okay, so in the current working directory, it will look for a Docker file, and based on what we have defined in the Docker file, this gets built and create an image with this image name and the tag. Okay, tag is, we can say, the version. Once we build this image, the next step is to push this to the target registry. Okay, so that step is docker push, then registry and image. So whatever image that gets built here, so it gets stored in the local Docker cache. Okay, so that is not going to get pushed to the or saved in the remote registry that we logged in over here, right? It will happen only once you push it. So that's why we are doing a push over here. Okay, so once we run this, it will create this image, it will push to the image registry. Okay, so let's do one thing. So this repository is set for automatic trigger. Okay, so let's say if you make any changes, so what I'll do is I'll make a small edit over here. So ideally, usually what happens is the developers make edit in the using the IDE or in the development environment, and then they do the commits from there. So I'm going to do it directly from the GitLab web UI itself. So if you see, I made an update to the title. This will show up over here. Then the title bar, I made an update, and let's see coder and boots nav. Yeah, I made an update in the title. Okay, coders here also in the heading also I am going to make version 2.1 to 2.2. Okay, so I'm committing the change. So if you see, once I did the commit, so one more thing to mention is I have a runner. Okay, I have a self-hosted runner so attached to this particular project. So whenever I do any triggers, right, so a pipeline will get created. Okay, and corresponding to the pipeline, a job. See, you see, we have a job defined inside that pipeline, right? You see, currently there is running 20 seconds. A job is running. It's in running state. It's pulling the image. So this job is corresponding to this particular pipeline. Okay, so pipeline, this is the pipeline, and then running, it has a job, build job. It will take few minutes to run, complete the execution. You can see running with GitLab runner, this particular version on Core Ubuntu, this system. So basically this is running over here. This is the runner machine, and I just hit docker ps. It is getting the runner ready. So right now something is running which is not related to the runner, but okay, the job got succeeded. Okay, so basically this was running when we logged in, right? No, sorry, this was running, right? This job, docker entry point runner. So this is the container corresponding to the build. Okay, later when I did docker ps, there was nothing shown, right? That means the job was complete. That's the reason. Container ID this one, image this one, docker entry point, and you see the name, it's runner hyphen something something, right? So this is the container corresponding to the job. Okay, and this job, what it did, it printed all the logs. Okay, so you can see it's doing docker login, right? Then it's printing the registry and the tag registry.gitlab.com code and boots awesome website latest. So this is the name of the image. Okay, so this is the name and this is the tag. Okay, first an image with this name gets created locally, then it's so during the build operation is where the image gets created. So as defined in the docker file, it's pulling the nginx image, okay, saving the image to this particular image name locally, okay, completed. Then push step. So what will happen, it is pushing to the remote registry with this name, okay, registry.gitlab.com code and boots awesome website, and the tag is latest. Okay, job succeeded. Finally it is saying pushed. Okay, so you can put your own tag, okay, and depending upon whatever is you need, you can define it in your docker file. So let's verify in the container registry. So in the inside the container registry, we will see awesome website, and we have something called latest when it published 2 minutes ago. So it's our job. Okay, so we published and it got pushed 2 minutes ago. So this is the build job. Okay, build job got succeeded. Now let's see how we can deploy. Okay, so deploy job, what I have done is I have created a different pipeline. Okay, so usually we create this deploy pipeline in a separate project. So I just created a separate branch and added this YAML. Here we don't really need any code base, we just need a pipeline. Okay, so here I have a single stage deploy stage, and there I have defined the deploy job. So what I am using is I'm using a local self-hosted runner. So that the runner is basically in this machine, and then I have the steps over here. I'm here also I'm using docker and docker. So and what I'm doing here is first I'm doing the login to the registry. Why we need the login? Because we need to access the image, right? That's the reason. Before script, this before script section will get executed before the script section. Okay, it will do the login to the docker registry, then it is going to pull the image. Okay, so the CA registry name image, so whatever image we are specifying here, the tag here we are specifying here, right? So and the image registry image. Okay, so this image gets pulled, okay, pulled from the registry, then here in this step gets pulled from the registry. Next what I'm going to do is, because this deploy job I'll do every time whenever I want a deployment. So first thing is I need to make sure I have to the container that is running that was deployed previously gets stopped. Okay, so for that purpose I am going to do this particular command, docker ps -- filter dot container name. Okay, so container name is the name of the container that I am deploying. So I am going to filter the running containers with this name, then whatever I found I basically stop it first, then I remove the container next. Okay, so it's the pipe arrow, whatever is the output it gets passed here, docker stop and the argument whatever is coming out from here. So stop it, then docker remove, this will remove the container. After doing the cleanup, what we are doing, we are going to run the image, right? So once we run, it will deploy it as a container. Docker run -p port. Okay, this is the host port and this is the container port. This is a web application, right? So host port and the container port -- name, this is the name of the container, -d is for detach, and then the image name. Okay, so this will deploy the image to the target. So this is a simple deploy pipeline, but depending upon whatever you like, it depends, the complexity varies, depends on your requirement. Okay, so maybe there can be options to change the configuration or make metadata updates. So based on the nature of your application, the complexity of the deployment pipeline changes, but this is a simple thing. This frame can be used for deploying any application. Okay, so I'll show one thing. So if you see here, clear docker ps, this is an already deployed application. It was deployed 28 minutes ago, right? So let's run this again. So this is in the deploy branch. Okay, so we'll go to the pipelines, build section, pipelines. We'll run the pipeline manually. Deploy pipeline, run pipeline. I'll select deploy branch, run pipeline. So it triggered the deploy job. So along with the deployment, we can have test jobs, everything. So it has right now, if you see, we have only one stage and one job, right? You can have complex deployment jobs, pipelines where you do the deployment, you do the testing, and you do the vulnerability testing. Testing means it can be multiple, okay? Vulnerability testing, functional testing, okay? So performance testing, okay? Then sending the reports, everything we can do as part of it. And then finally maybe we can say we can declare like the deployment is successful based on the test outcomes. It will take few minutes to do the deployment because it has to pull the image. The image pull and all depends on the machine's internet bandwidth, because right now it is pulling from internet to my runner node. But if the image is available locally, then it won't take this much time. Yeah, it is executed and it is doing the final cleanup. Job success. So as we defined, docker pull the image, docker, okay, remove. So here you see it found some container which is already running. So if you see this is the container which is already running. The ID is matching, right? Starting with 5, ending with D. So for starting with 5, ending with D, then this was stopped and removed. Then docker run the new image, okay, new version. It will deploy the latest app. So let's do docker ps again. So please note the previous time it was deployed 28 minutes ago. Now if you deploy, you see up 45 seconds ago, right? So the latest app is deployed, okay, and 8080. So let's open this in the browser. So it's a local VM, okay. So yeah, see v2.2. Previously it was v2.1, right? So the change that we made was v2.2. Okay, I hope this is clear. Now quickly I will explain the deployment of a Python, build and deployment of a Python program. So here I have a Python code in this particular branch. So I have not created like a very complex Python program. What I have is a simple Python program, and I have not followed any directory or package structure or anything. What I did is I simply placed the app.py directly on the home directory itself, root directory itself. I have a Docker file, I have a requirements.txt, and I have a GitLab CI. Okay, so in the app.py, what I have is a simple Flask web service. Okay, so it's a simple Flask API. It has one endpoint /API. Okay, and that runs on port 8000. Okay, so that means once I run this, the app will be running on port 8000. This is internal to the container. Okay, then if you see the requirements.txt, I have one requirement. It is just Flask 3.0.3. So when we do the requirement.txt, always make sure you specify the version of the package over here. Otherwise, every time you build, it will always pull the latest package from the PyPy repository. So then Docker file, here also simple thing. I am using the Python Alpine, okay, this particular version 3.9 Alpine. So depending upon the program, right, you can take either maybe the full version of Python, which is just Python 3.9. Alpine is a lightweight version of Python image. So it's up to you. You can pull the Python image or your custom image or whatever you want. Then I'm setting the work directory. I'm copying the contents from the root of this project to /app directory. Okay, then I'm running, okay, pip install requirements.txt. So whatever packages I have in the requirements.txt will get installed as part of this. And at the end, I'm doing Python app.py. That means once I run this container, once I run this image, the app.py will get triggered. So that's the idea. So GitLab CI, it is the same. I just use the same GitLab CI as what we used for building the UI. because we are not going to do anything else, right? So in the Docker, the only change was the Docker file. So that anyway, whatever is there inside the Docker file gets built at this stage, and it gets pushed to the image registry. And what I have done is, as we have a UI code with latest version, I have made an update to the image tag. So I am using v1.0. okay, so that means v1.0, the image gets committed to the package image container registry with the version v1.0. okay, so let's quickly trigger this job. Okay, so for triggering this job, what we need, if you make a small change in the program or whatever you, or maybe you can even trigger from the pipeline. Okay, so let's do let's make a small change in the program itself. I'm just adding a comment. Commit changes. This is a small change, so this will trigger a pipeline. Okay, so now let's go to build pipelines. You will see a pipeline running. Okay, let's get into the pipeline, build job. This is doing the same thing. It will build the image. It will take a while. So I have explained all about GitLab runners, self-hosted runners, everything, in the previous videos. So you can watch those videos to get a very good understanding of the self-hosted runner, GitLab runner, everything. You can check this machine. Yeah, it's doing the build activity. You see, docker build -t. Okay, then it's pulling the base image Python. Okay, then setting the work directory. You can see the Flask package is getting installed. This is pip install -r requirements.txt. Flask package is getting installed. There are some other dependent packages for Flask. Those are all getting installed, right? Then it's finally it's all done, right? The image got built. Now it is pushing into the registry with the tag. Okay, so it is pushing it to as v1. So you see at the end it's pushed. So we are waiting for the final message, job success. Yeah, job succeeded, right? So let's go to the container registry. Okay, so here we can see the v1.0 tag, and it is published right now. Okay, the build is success, right? So the deploy job is similar. So we have already discussed and explained a few minutes back. So here we can use the same deploy pipeline. So what we need, we just need to modify the tag, right? So what we can do is, so this tag, even we can, instead of like hard coding the tag, what we can do is we can even use it as a pipeline variable. Okay, so that at the time of running this one, it will ask for the tag name, and we can just deploy this. Okay, so it's 80 external port, and internal we will make 8000. Okay, because internally within the container the port was 8000, right? External I will make it 8080. So I think it will image name is awesome website, tag is v1. So no, the image name is yeah, it's awesome website only. This is the container name. The tag is v1.0. It will pull the v1.0 tag and deploy it on port 8080. Let's see. Just made a change, so I don't have to trigger it again, because it will automatically take care of the trigger. Running. The idea is this should deploy the application in the target environment. It's doing the deploy operation. It will take few minutes to complete the deployment. The process is the same. It's a very simple. It will just pull the image, do the deployment, clean up if there is something running. And if it is right now I have used the deployment to just Docker, but if you want to deploy it to Kubernetes, then instead of Docker run we can use the kubectl apply command. Okay, so depending upon the target environment, the deployment commands will vary. Based on that you can modify the pipeline. So here for simplicity I have just explained the deployment to Docker. So I'll make another video that will deploy to Kubernetes. So right now the deployment job is complete, so ideally it should be running on the port that we have defined is 8080, right? So it should be running over here. So let's do docker ps. Now you see there is awesome website v1.0 running. Okay, 8080, it's outside it is 8080, internal 8000, right? It should be running over, it's running over here. Let's see what colon 8080/API. Okay, so it hit the API. So I think there is a huge JSON behind it. That's the purpose of that API. It will take some time to render, but because I think the JSON size was huge, that's the reason it is taking time to render. But this API is accessible, available. Okay, so yeah, this is the response. You see the payload. So this is a huge JSON, that's why it took some time to respond back. Okay, pretty print. It's around like several MBs, so it's around 40 MB JSON. That's why it is taking time to render in the page. Okay, there are several ways to optimize the payload and all. So but this is just an example of showing it on the screen. You see the browser became unresponsive because of the size of the payload. Okay, I hope this example is clear. So if you have any questions or feedback about this video, feel free to comment below this video. I'll respond back. Thank you very much for watching this video.